Hello, my name is Raul Cornejo, and this is the video for the final design project for class EEE3303 Lab Electronics 1. So my final design project that I chose to do was to create a high-pass filter so it could be connected to a bass guitar, so I could just play regularly on a regular guitar amplifier without the need of having a bass amp. So I actually made two different design prototypes. This one is just a passive high-pass filter. I made a toggle switch right here to bypass if I wanted to the filter itself. And here's the design and specifications for this filter. The passive high-pass filter, I used the 0.047 microfarad capacitor, a 470 ohm resistor, and right here. I had to use a mono audio jack, one for the guitar input and one to go out to the amplifier. And here, guitar input, this to amplifier, and then here's this switch right there to bypass the filter itself. So I calculated the frequency cutoff to be the 7.20 kiloohms for this filter. Originally I had planned it for the frequency cutoff point to be lower, specifically, ideally around this range, which ranges from 100 to 1 kilo. And this is the graph for the guitar amplifier, guitar speaker phone and the amplifier which I have. So I would have preferred this range, but unfortunately it would cause too much distortion when I had the frequency cutoff point that low. So I had to go much higher. So it's around here now, 7 kiloohms. It's a much lower decibel output of the speaker, but that's one problem with the design. But the good thing is that it actually produces clear notes from the bass guitar itself. And here's the other version I made. This is an active high-pass filter, and the reason I made this is because some volume was lost with the passive high-pass filter. So I made this. I just got the diagram in here. I used the 741 op amp with a 15 volt, negative 15 volt, supplying the power for the op amp. Once again, the guitar input. There's a capacitor and points. So again, what's same as 0.047 microfarads. R1 is right there for 70 ohm resistor, and I put this 1 kilo potentiometer, so that hoping that the gain could be adjusted, and then probably make the output of the filter higher or lower. Type that in. You can see here. Here's the diagram. Once again, the mono jack for the guitar input, and then here's the output. There's the op amp, and that no switch made for this one. This one's just connects straight to that. So I will focus on the passive filter first. Well, to the testing for the experiment and the design, I used this Fender Bass 6 bass guitar. And I used this small Fender Mustang Mini practice amplifier. And this is the amplifier I used first whenever I did the initial designs with the initial circuits for the low pass filter. Just because it's a practice amp, I'm not too worried about the speaker or anything blowing up in this one. So that's why I used this one first before actually going to this much bigger orange CR60 amplifier. And this is basically the final amplifier, and I did the final testing with to see if it worked with that, it should work with this. So just to see that it stays. Keeps working no matter what amplifier, what speaker it's subjected to. But again, this is my gigging amplifier, so I'd rather not blow it up or damage it too much. So that's why this was used in the final stages. So here's the filter itself, now connected to the guitar and the amplifier. This is the white amp cable. This from the guitar. You can see here. There's the guitar. So that goes to the input. Well, actually, first it goes through this toggle switch, and this switch basically is used to select whether to bypass the filter or to actually engage a filter. Right now it's set to engage a filter. There it's just a bypass and just a simple jumper that goes straight to the output. But in here it goes through the 0.047 microfarad capacitor and the 470 resistor in parallel, and then here's the output, which goes to the cable, the black, and this goes straight to the amplifier right there. So now I'm just gonna play the low open E string. So this is with the filter on, what it sounds like. I'm sorry, my bad. One more time. And I'm gonna switch the filter off. This is what it sounds like, the filter off. I hope it's got a stronger bass response, and that's also a higher volume because the signal strength is lost as it passes through the high pass filter, so it causes lower volume. Here are some subscope measurements made with the passive high pass filter. And here the filter is bypassed, so I can actually just see the bass guitar input signal just going straight out to the amplifier. So this is from the input of the bass guitar, it's in green, and this is the output of the bypassing of the bypass that goes straight to the amplifier, and that one's in blue. As you can see that the green input signal is a bit more stronger, it's more strength, more amplitude than the blue signal that's going into the amplifier. So it's all nearly identical, so no volume losses really caused. Unlike here with the filter turned on, that's a completely different. Here I got the scale for volts per division for the green, which is the input, the bass guitar input of 50 millivolts, and the output is the high pass filter is at 10 millivolts. So in here you can see that the value is actually much higher, and here's the volt peak to peak of the guitar signal, 120.73 millivolts, while the output of the filter is just at 43.96 millivolts. That's a lot of difference. But another thing that's interesting to notice is too that you can actually see how the signal has been changed to have much higher frequency after the input signal goes to the high pass filter. That's actually really neat to see in there in action. I'm gonna put the filter off again and show some more benefits of actually having using this high pass filter. For example, like if I wanted to play chords with just the regular bass input, a lot of distortion is caused. It's nasty. Sounds nasty. I'm gonna turn it on. Alright. And then makes a different sound now. And this is the same thing I tried playing last time. Same chord. But it's not muddy anymore. There's very little distortion. And it sounds good. Which is great because I can use this guitar to double, this bass to double as a guitar. It sounds very interesting to the soul because it's not as bright as a guitar, but it's not as deep as a bass. It's an in-between mixture, so it creates new musical opportunities. Okay, so now time to switch gears and go to the active high pass filter. So I got everything hooked up. Here's the white cable coming out from the bass, and here's the black cable going to the amplifier, and here is the MIDAC supplying the positive 15 and negative 15 volts to the op amp, to 741 op amp. And I'll show you the reason why I'm using the smaller amplifier in this case and not the big one. Noise. Just produces noise. That's it. fortunately this prototype was a failure. It's just noisy. It's too noisy to be used. That's all it makes is noise. That's happened after I added in the op-amp, the 741 op-amp. So it seems that the op-amp itself is just too noisy to be used for this type of thing. And fortunately, I couldn't make a working active high-pass filter. I was hoping with this I could use the gain, the potentiometer to adjust the gain of the guitar, and basically just adjust the volume as well. But no, it's just noisy. So the passive high-pass filter remains the best prototype out of these two, and this is honestly the best one to move forward with. The results are, this is basically the end of the design, but if I was to make any improvements or just keep working, I would want to add get all this, instead of being out here naked in the circuit board, put it in the actual box enclosure, so that way I could make it look neater, and also not have so much problem plugging in the stuff and preventing any disconnections. Like here, I just pull this out, so that's why better to just be soldered onto like some sort of case, and then this is on a small circuit board card. Well, the other thing I could possibly look into is, instead of using a 741 op-amp, I might want to use a different source of amplification, whether it be an operation amplifier or a transistor. I've seen many guitar pedals like use a 9-volt supply as well, so I'm probably just looking around which op-amps or transistors I can use that 9-volt to supply this power with, so I could easily use a 9-volt guitar. And then that's probably about it as far as improvements, and that's it. Thanks for watching.